Hello and welcome to an introduction to statistics for social workers. In this course, you'll be learning a lot of new terminology. Let's review a few terms. The first term is data. Data are the measurements that are collected in a research study before they've been analyzed. Data analysis is driven by the research questions being asked. One important thing to know is that data does not equate to knowledge. We derive knowledge from data, so how we interpret the findings from a research study determines what knowledge is produced. Another term is data sets. A data set is a collection of related sets of information, and this collection is composed of separate elements but can be manipulated as a unit by a computer program. Another useful term you will need to know is variable. A variable is a trait or a characteristic that can differ in quantity or quality among people or objects that are being studied. The term variable means that the characteristics vary. For example, in a data set of high school students, age would be a variable because students in high school can vary in age. When a characteristic does not vary, it is called a constant. Constants are consistent traits or characteristics. For example, in a data set of female juniors in high school, the variable gender would be considered a constant because all students in the data set are females. Also, when we conduct research, we use conceptualization to identify which are the most important variables we wish to study. For example, a variable of interest might be trauma in veterans. Conceptualization also involves stating exactly what is meant by each variable. In other words, conceptualization means that we define the variable. Many concepts may be abstract. Therefore, conceptualization involves making abstract concepts specific and precise. For example, being diagnosed with post-traumatic stress disorder might be a way we identify stress in veterans. When we operationalize a variable, we specify how we're going to measure the variable. For example, we might measure the severity of post-traumatic stress disorder by using an inventory or scale designed to measure trauma symptoms. And when we conduct a study, we need to consider measurement issues. Two measurement issues are reliability and validity. Reliability is the degree of consistency in the way we measure variables. For example, if we give a person the Beck Depression Inventory several times during the same day, we would expect the score to be relatively consistent. Consistent scores are said to be reliable. Validity determines how well the instrument measures what it's supposed to measure. For example, if an inventory or scale is supposed to measure anxiety, then it should measure anxiety and not depression or any other type of mental health symptom. In other words, if an instrument or scale has high validity, we can be confident that it measures what we want it to measure. All variables have characteristics. We can describe a variable as being categorical. A variable that is categorical describes things that fall into categories or groups, such as gender, race, or political party. We could also describe variables as being continuous. Continuous variables are those that describe things that are numerical, such as age, weight, IQ score, or temperature. One very important thing to know for this statistics course is that variables have characteristics. A variable's level of measurement defines the nature of that variable and determines what statistical methods can be used to analyze the variable. There are 4 levels of measurement: nominal, ordinal, interval, and ratio. Let's review each of these. Nominal level variables are the lowest level of measurement. These are categorical variables that fall into groups such as gender, race, or political party. The next measurement level is ordinal. Ordinal level variables are also categorical variables that have some order or rank, from low to high or small to large. For example, class rank, such as being a freshman, sophomore, junior, or senior, would be an example of an ordinal level variable. Another example would be the level of satisfaction that are often measured on surveys. For example, you may respond to a customer satisfaction survey that asks whether you are totally satisfied, somewhat satisfied, or totally unsatisfied. The next level of measurement is interval. Interval level variables are continuous variables, which means they are numerical. Interval level variables are equally spaced on a continuum. Temperature is an example of an interval level variable. The degrees on a thermometer are evenly spaced. There is the same distance between 1 degree and 2 degrees as there is between 99 degrees and 100 degrees. The last and highest level of measurement is ratio. Ratio level variables are the fourth level of measurement and are also continuous. This means they are numerical values that indicate the actual amount of the property being measured. For example, age, height, and weight are all continuous ratio level variables. There is sometimes confusion distinguishing between interval level and ratio level variables. Let's review some examples. Nominal level variables are fairly easy to recognize. They are variables that fall into categories and cannot be rank ordered. For example, if we had a category called animals, it could include items such as cats, dogs, cows, or pigs. These are clearly not numerical and cannot be rank ordered. Therefore, animals is a nominal level variable. As mentioned, ordinal level variables are also categorical variables, but they are rank ordered. We see ordinal level variables most frequently in surveys that ask respondents to select some type of ordered response, for instance, from low to high or small to large. Some examples of interval level variables are time, IQ score, and temperature. The difference between an interval level variable and a ratio level variable is that interval level variables do not have a true 0 point. For example, the time on a clock would be considered an interval level variable because there's no true 0 value. It begins at 12 a.m. and ends at 12 p.m. The units, which are the seconds, hours, and minutes, are all evenly spaced. For instance, the distance between 1 p.m. and 1:01 p.m. is 1 minute. Likewise, the distance between 6:05 p.m. and 6:06 p.m. is also 1 minute. Each time unit is evenly spaced. Temperature is also considered an interval level variable because there's no true 0 value. Of course, we could have a temperature that's 0 degrees Fahrenheit, but 0 degrees Fahrenheit is not the same as 0 degrees Celsius. Therefore, there is no true 0 value on a thermometer. IQ is also an interval level variable because there is no true 0 value. Like interval level variables, ratio level variables also have evenly spaced units. However, ratio level variables have a true 0 value. For example, the number of children would be considered a ratio level variable because it's possible to have 0 children. Likewise, amount of money earned for a year or height measured in inches could also be considered ratio level variables. Table 1.1 shows the characteristics of the 4 levels of measurement. All 4 levels of measurement can have more than one attribute or value. If the attributes or values are rank ordered, then the variable cannot be nominal. If there is equal distance between each of the attributes, then the variable cannot be nominal or ordinal. And if the variable has a true 0 point, it can only be a ratio level variable. Although it's important to know the difference between each of the levels of measurement, for the purposes of statistical analysis, interval and ratio level variables are often treated similarly. There are many ways to describe variables. One type of variable is called a dichotomous variable. A dichotomous variable is a specific type of variable that has only 2 attributes or values. For example, if you were taking a true or false test, the response would be dichotomous because you can only answer true or false. There is no third choice. Another name for a dichotomous variable is a binary variable. Please note that in data sets, dichotomous variables are sometimes represented numerically by using ones and zeros. For example, in a data set of responses from a true or false test, true answers might be coded using ones, while false responses might be coded using zeros. When we use ones and zeros to replace categories in binary variables, we call this dummy coding, or refer to these variables as dummy variables. Next, let's review a little bit about research hypotheses. A hypothesis is a researcher's educated guess as to the outcome of a study. In other words, based on existing knowledge, a researcher predicts what effect variables will have on each other. There are two types of research hypotheses, one-tailed and two-tailed. A one-tailed research hypothesis is one that predicts a relationship between or among variables and moves in a specific direction. One-tailed research hypotheses are also called directional hypotheses because the relationship between variables moves in one direction. For example, we might hypothesize that as age increases, so does weight. In a two-tailed research hypothesis, the researcher states that there is a relationship between the variables but does not specify direction. Two-tailed research hypotheses are also called non-directional hypotheses because the relationship between the variables can go in either direction. For example, we might hypothesize that as age changes, weight changes. In this hypothesis, we are not stating the direction of the change, only that there will be some type of change among the variables. Another type of hypothesis is called the null hypothesis. A null hypothesis states that two or more variables are not related. In other words, the null hypothesis states that any change that occurs among the variables is due to chance and not because one variable is having an effect on another variable. The way our research hypothesis is stated can communicate much information. For example, it can suggest which variable is of primary interest in the study, and what other variables may be believed to be related to the attributes or values of the variables of interest. For example, a hypothesis might be stated as follows. When controlling for age and gender, level of stress decreases grade point average in college seniors. This hypothesis tells us that the researcher predicts that the level of stress will have a negative effect on grade point average, specifically in college seniors, and the researcher will control or account for the effects that age and gender have on grade point average. In this example, age is a control variable, gender is a control variable, stress is the independent variable, grade point average is the dependent variable, and college seniors is the population. One of the ways we can classify variables is based on their relationships. Two primary types of variables are the independent and dependent variables. Independent variables are considered to be the cause or the predictor variables. In other words, the independent variable is predicted to influence or cause change in another variable. The dependent variable is the variable that is predicted to be the one influenced or affected by the independent variable. In other words, the dependent variable is considered the outcome. Some other types of variables include confounding and extraneous variables. These variables can have an effect on the outcome, but are not of primary interest. For example, if we were examining the effect of a particular type of therapy for depression, some extraneous or confounding variables might be whether the person has support from a family member, is taking medication to treat the depression, or if the person has a co-occurring physical illness. Researchers try to control for these types of variables in order to account for or reduce their effects on the outcome. Another term you should know is covariance. Covariance simply means that the two variables vary together. For example, height and weight are two variables that co-vary. When one changes, the other changes. The variable that is used for prediction is called a predictor variable. The term predictor variable is oftentimes used interchangeably with the term independent variable. The variable whose attributes we are most interested in and hope to predict is called the criterion variable. In the example of a hypothesis where it is hypothesized that the number of hours studying is related to higher grades, the number of hours studying would be the predictor variable and grade would be the criterion variable. The type of statistical analysis can be categorized based on the number of variables in the analysis. A univariate analysis has one variable. A bivariate analysis has two variables. And a multivariate analysis has more than two variables. Analyses can also be categorized by the purpose of the analysis. Descriptive analyses focus on data reduction, which means that the data are simplified for analysis. Population parameters are the statistics within the population, such as the racial breakout. Sample statistics are the statistics in the sample selected for the study. Just a note about population versus sample. It is often not feasible to study an entire population, which is why researchers select a subset of the population to study. This subset is called a sample. Remember, the term parameter refers to characteristics of the population, while the term statistic refers to characteristics of the sample. Inferential analysis occurs when we try to predict or draw conclusions about the larger population from the smaller sample. Research design and statistics can also have an effect on how a study is conducted or how the data are analyzed. For example, the purpose of a study can be exploratory, descriptive, or explanatory. Exploratory designs examine new phenomena, those that have not been previously studied or have not been studied very much. Descriptive designs describe the phenomenon of interest, and explanatory designs attempt to establish cause and effect relationships. Studies can also be classified according to the number of times a variable is measured. In cross-sectional surveys, the variables are measured once at a particular point in time. Pre-test, post-test studies measure the variables before and after a particular event, such as an intervention. And longitudinal studies measure a phenomenon over time. For example, a longitudinal study of autism might follow children from birth into adulthood. We can also classify studies according to the number of groups in the research study. There may be just one group that is being examined, or there may be two or more groups being examined. Also, it's important to understand the objectives of the study, that is, what the researchers are trying to accomplish. The most important thing to remember at this point is that certain research designs rely on certain statistical tests. This means that the type of statistical test that is used depends on the design of the study.